Hello students. So this one is a physics lecture. We are now going to start our assessment 3 course. For the assessment 3, I am starting your chapter space physics, which is the last chapter of your book, but it has a direct link with the initial chapters, so I will cover this one first. In this chapter, which is basically having a two sub chapters in it, 6.1 and 6.2, we will study about the space around Earth and also the cosmological region, which is also referred as a deep space. So in the first chapter, which is the 6.1, we will just cover the space around the sun, in which we will include our solar system, different planets and their moons, and the arrangement of the planets, etc. And in the second chapter, 6.2, we will move to the deep space region, which just directly link with the evolution of our stars, including our sun and other cosmological facts. So the start of this chapter 6.1, you will see the topic named as the Earth. So in this topic, we will cover the motion of the Earth around its own orbit and around the sun. Means the Earth have two type of motion or the rotation. One is referred as a spinning and the other one is referred as a orbital motion. The spinning of Earth basically take 24 hours, and that is the main cause, like the spin of Earth is basically the main cause of day and night. On the other hand, the orbital motion, which is also referred as a revolution, is just the motion of a Earth around the sun. And we all know it just took almost 365 days or 1 year to complete one orbit around the sun. Orbital motion or the revolution of the sun around the sun is basically the main cause of our seasons. Every object that is spin or rotate about its own axis, we just take the axis usually at the mid of the object. So an axis or a perpendicular that is passing through the object is referred as the axis of rotation. So if the object is spinning in the anti-clockwise way, this perpendicular will refer as the axis of rotation. For Earth, the axis of rotation is not exactly at the midpoint. So if this one is the Earth, if this one is our Earth, its axis is exactly not at the midpoint. So I'm taking as a 0 degree here. So in actual, we have the axis a tilted one in that way. So this one, the actual axis of rotation for our Earth. So our axis of rotation is not exactly perpendicular to our Earth. It has some tilted axis. So that's why we sometimes refer that as a tilt axis. So that's why if you just see any decoration piece that have a revolving earth in it or the spinning earth in it, you will see the earth is not exactly in that way. It has just some tilted angle. And that tilted angle basically the main cause of our seasons and the difference of the season for the northern sphere and for the southern sphere. Definitely I will explain that later. So it's not a distance that change the season, it's our tilted axis of rotation that is the main cause of the season. So that is the main point, so I'm writing that one like this. Tilt of axis is the main reason for seasons, not distance from sun. So usually we have a myth like the when we just get closer to the sun we get summer, and when just we move far away from the sun we get winter. It's not in that way. Basically the tilted axis is the main cause of the season, and that one is also the main cause we get a different season for the northern hemisphere and for the southern hemisphere. And I will explain that one later. So now we get that okay, the earth axis is not in the perpendicular way, it has some tilted one. But how much degree this one is tilted, and this one is also the important information. Few MCQs have covered this topic or this thing. So you should know the earth tilt angle is basically earth tilted at about 23.5 degree. So just keep that number in your mind. So it means if this one is a 0 as a reference to the axis, so this angle is basically 23.5 degree. Now you will see a different terminologies while reading this topic on your book. Okay, I will also show you a image here so you can get the picture. You can see in the image our axis, so this one is the sun definitely, and the earth and the equator. So the equator is not in that way because the axis is not this one. So we have the actual axis, this one, which is around 23.5. So few data say the 23.4, but your book refer to the 23.5, so you will go with that. So 23.4 or 5 degree tilt towards the sun. So that's why the earth basically appears the tilted way. Now you will see a different terminologies in your book, and I will write the terminologies here and also will give you the idea. So the first terminology you will go through is the solstice or the solstices. Solstice basically referred with the special days in a year that are the longest and the shortest days. So the longest day we just referred as a summer solstice, and the shortest day we just referred as a winter solstice. But remember, these names are due to the northern hemisphere. Like according to the north pole direction. Now I will tell you about the summer solstice. So summer solstice basically the longest day often marks the beginning of a summer and it is referred as a summer solstice. Like you can see here, the day is longer and the night is shorter. For our region, we get this day usually around 21st June, which is considered as the longest day of the year. On the other hand, the winter solstice, which is also known as the shortest day, in which we get a long night, usually appears around 22nd December for our region, and that one is referred as a winter solstice, in which we get a very little day or the shortest day and the long night. So the word solstice means the longest and the shortest days of the year. Solstice. So during the summer solstice, we get this type of situation. Here you can see the North Pole is tilted towards the sun, and the South, on the other hand, is tilted away from the sun. The important points you should keep in the mind. The important point you should keep in the mind for summer solstice. Northern hemisphere tilted towards the sun. Longest day and the shortest night. And it occurs around 21st June. Now, on the winter solstice, we get a longest night and the shortest day. And here you can see the North Pole is tilted away from sun and the South Pole is tilted towards the sun. For the winter solstice, the important points you should keep in the mind are northern hemisphere tilted away from the sun. We get the longest night and the shortest day, and it occurs around 22nd December. The, the second terminology you will see in your book is about equinoxes. Equinoxes mean equal day and night. Here you have 12-hour day and the 12-hour night. We get two such type of equinoxes in a year. First one is the spring equinox, happened around 21st March, and the second one is autumnal equinox. It just happened around the 23rd September. On the equinox days, the sunlight is directly above the equator. So here, as the reference image I'm sharing here, you can see the equator, which is usually we take that as a 0 degree, and if we make a giant poles on the both side, the northern hemisphere and the southern hemisphere, depending on the distance from the equator, the shadows are equal in size but opposite in direction. So here you can see that. So that's why, that is the main reason for the southern hemisphere the season are reversed. I will give you a reference image for the northern pole towards the sun. which we get in the summer season. Here you can see this one, the green line is the North Pole here, and definitely the sun is at this side. So here you can see the major portion is getting the sunlight. We have a summer season here. We have a region named as Arctic region which get a 24-hour daytime. So that region is referred as a Arctic region. So the Arctic region, you can see this region. So the countries or the areas that are in this region are referred as Arctic region, and they get few days or at least one day in such a way like for 24 hour the sun not set. So like the full day, even at the midnight time. And you will also see some kind of videos for that areas. During that time, the southern hemisphere, you can see it's away from the sun, though, so the southern hemisphere have winters. Now, for the situation where the northern pole is tilted away from the sun, so northern pole tilted away from sun, we get the situation in that way. So here you can see again the sun is at this side, is the sun rays, and this one is the north pole, and here you can see even on the complete rotation this region is not getting any sunlight. So the regions where the 6-month day and 6-month night is basically they are at that location on the earth, the sunlight due to the tilted axis appeared or not appeared throughout the year. Okay, now if we consider the overall orbit of earth around sun, it's not a perfect cycle, it's not a perfect circle, it just appears in the ellipsoidal way. So the reference image is here. So the orbit of the earth around the sun is not a perfect circle, it's a shape of the eclipse, and even the sun is not at exactly at the center. That's why where the sun, where the earth is the closest to the sun, that one, that is a position we refer that as a perihelion, and where the earth is the farthest point we refer that as a aphelion. So the key points that I'm going to write for you is earth axis is tilted at 23.5 degree due to earth rotation around its axis. We get day and night. Due to its revolution around sun, we get the seasons. days, we have two solstice days, longest and shortest days. We have equinoxes days, equal day and night. And the most important thing that you should keep in the mind, northern and southern hemisphere have opposite seasons. I'm also sharing another image here so you can get the tabular form for both region, northern hemisphere. So the days are here and the regions are here, so you can see where we get the summer, southern get the winter. Here we have a autumn season, southern has a spring season. So that's all for today, and if you have any question, feel free to ask me. You can comment on the video, you can send me a message. Take care, Lafis.